You should know these properties of rational exponents. When I multiply a similar base, a times a, I add the exponents. The only time I multiply them is when one is outside of the parentheses. It's the only time. One outside the parentheses means everything inside gets one. If it's to a negative, it means any negative exponent means it wants to move things. If it's above 1, it goes below. If it's below, it goes above. If I am dividing similar bases, I subtract their exponents, the bottom from the top. And again, everything on the inside gets the exponent if there are parentheses. Mostly because it's a to the 1, so it's 1 times m, and b to the 1, so it's 1 times m. But anyway, that's the effect. And here's an example problem. We're just going to go ahead and do this. This first one is a little bit sneaky because what we can say here is I can rewrite this as 3 to the 1/4 times, you know what 27 is? 27 is 3 to the 3rd, right? So, because 3 times 3 is 9, times 3 is 27. And then I can multiply my exponents. So now I have a common base when I multiply these together. 3 over 1 times 1 over 4 is 3 over 4. And when now that I have a common base, before I did not have a common base, okay, but now that I have a common base, I can add exponents. So when I do that, I'm going to get same base, common base, 1/4 times 3/4, that's 1. I guess I'll write 1. I don't usually write 1, but it's just 3. It's just 3. Okay, I'm going to multiply. I have 7 to the 3 over 1 times negative 1 over 3 over 4 to the 3 over 1 times negative 1 over 3. Well, hopefully you're not too surprised to find out that this gives me 7 to the minus 1, 3's cancel, and 4 to the minus 1. And those negatives tell them to move. The 7's on top, it tells it to move to the bottom. The 4's on the bottom, it tells it to move to the top. So now I have 4 to the 1 on top and 7 to the 1 on the bottom. I'm just going to write it without the 1's. Why should I have to write the 1's? So it's 4 over 7. Okay?